Good day, people. Good day, people. This is EA Lego Academy. My name is Eliaza, and today we would be continuing our Python tutorial series. Now, today we are going to be looking at files and exceptions, and I will just give a brief definition of what files are and what exceptions are. So I would no longer be copying and pasting my code. I would be writing it out so that we can be able to see the workings of how program is built from scratch, and I would be giving explanations as well as I do that. So files and exceptions. So files, this is when we create files and then we manage errors in our code. So that is a combination of both definitions of files and exceptions. So files, we can create files in Python by through writing code. So we can use code to create files, and exceptions just simply means errors. The exceptions are errors in every programming language you might be working with or working on. When you hear the term exceptions, exceptions mean errors. Now, files, before we dive into writing code and looking at syntaxes, files are determined by their extension. So an extension determines the format of a file. A file can be a Python file, and for a Python file, the extension, the way we can determine that a file is a Python file is by the extension .py. Likewise, for a text file, the way you can determine that this file is a text file is by the extension .txt. Database files, .db, SQL files, .sql, and so on and so forth. So an extension determines the format of a file, even down to executables and applications that you might execute on your devices, such as your laptop devices, your desktop devices, or your mobile devices. So for mobile, specifically Android, we look at .apk. So .apk is actually the extension of that file. It's telling us that that file is an application. Also for a desktop application, we have .exe. .exe means executable. So it means that that file is an executable file, meaning that it can run, it can display a window, it can run on your operating system, your Windows operating system. All right, so let's continue. So files. Files are documents whose contents are determined by their extensions. And exceptions, we said that it's another name for errors encountered in any type of programming language you decide to use. So let's look at reading from a file in Python. So reading from a file. So before we start writing code, you want to, so I assume you have been following my previous tutorials. So where I walked you through how you can install Python on your system, set up your integrated development environment, create a project, create a Python file inside that project. So I've walked you through all that. So, but I will be doing that again. Specifically for this course, I will be showing you how you can create a file. So this was where we stopped at. We stopped at dictionaries in my previous tutorial. It's been a while. I was busy. The reason why I haven't been online for a while, because of course this is not the only thing I do. So I have other things I do. So now I'm back, and I intend to put up that momentum, rather keep it up, so that I can finish this tutorial series. We would soon enter the next phase of this Python tutorial series, which is creating graphical user interfaces and also working with a database management system. So without further ado, let's get started. So you come now, I opened up my my PyCharm IDE, and this was the folder we worked in. You can see my previous files that we created in our past tutorials. So, okay, so this is not the actual folder. Okay, so let's assume that you haven't opened up yours yet, because I don't think this is not the folder, this is not the project I was using. So in order to do that, I'm assuming that we all have PyCharm, because I walked you through in my first tutorial how you can install PyCharm on your operating system. So now it's assumed that you have PyCharm installed on your operating system. So you want to click on the file icon at the top here. You want to scroll down to recent projects, because I assume that you have already created your project and you are working in it already. So I will just trace mine. All right, so I think this was a project, variables and data types. So this was the project I started with us for this tutorial series. So I will click on that and click on this window to open it up. So this was where we stopped, and we stopped at object-oriented programming, which is classes. I'm not too impressed with the views I got, with the reviews I got. I didn't get any likes for the video, but we keep pushing and we keep doing what we have to do. So since you guys have, it's as if no one wants to communicate or let let me know where they had problems. It's all good. So now what you are going to do, you are going to come to your folder name, right click and click on new. Then you would come down here, click on Python file, and you would give it a name, reading file. So we want to look at how we can read from a file. Now, to do that, now before you can read from a file, you have to make sure that that file is in existence. Read from a file. So you want to make sure that that file is in existence. As you can see, I haven't created any file that I intend on opening. But to make it very simple, we are going to create a file manually first of all. Then I would show you how you can use Python to do the exact same thing. But before that, we are going to create a file manually, and then we are going to write some things in that file, and then we are going to come back here to this our reading file.py and see how we can read the text we wrote to that file. So the file is just going to be an ordinary text file. It might not even be a text file because I'm not going to put the extension, but of course PyCharm already puts the extension for us. As you can see from the when I wrote reading file, I didn't put .py, but because I clicked on Python when I was creating this file, PyCharm already knew that the file I was creating is a Python file. So you don't have to specifically put an extension before your PyCharm would know that that file is a Python file. All right, so now you want to come here to the folder again. We want to create a file from which we are going to read text from. So you right click, click on new, then you come here to file. So this is already a text file already. So click on it and you can just give it a name. I would call it reading as well to make things simple. Now I have created a file called reading, and I want to write some text to this file. So how do I do that? I will just write, hello there, I am a file. I am a file. Then full stop, first line. Then you come down to the next line by pressing enter and say, hello again. I am the next line for file. It doesn't matter what you write. It doesn't matter. The point is that we want to be able to read from this file and display the result on our console. So you want to head back over to your Python file, your reading file.py, and we want to write the code for that. Now, I'm going to create a variable that would represent this file. Now, this variable will take this file as a value. Now, one thing you should note is this. When you are creating a variable for a file whose content you intend to access in PyCharm, you want to make sure that the name of that file is written within single or double quotes. Python treats that file as a string value. So I would create a variable. I can call it contain, doesn't matter, is equal to, open up a double quote or a single quote and write reading, the name of the file. After that, you can come here and say with open. Now we have a command in Python called with open. Now, for those of us who are familiar with object-oriented programming languages like Java and C++, you will notice that in order for you to access a file, Java has a class that allows you to access a file called the file class, and it has another class called the file writer class in order for you to write to a file. But Python allows us to implicitly refer to the file class in Python by writing this command. So we are also referring to a class in Python that allows us to access a file by writing the with open command. And this command has two string values. Now the first string value is R. The first string value is a R. Now the R allows us to read, rather it has three actually, not two. It has three string values. Now the first string value is an R, which allows us to read text or characters from a file. Now, it would be assumed that that file would already be in existence before that string value can read the content from that file. So what I'm going to do, because I have already created a representation representing this reading file, which I created, I am just going to pass that representation, which is contain. It's a variable now, which now represents the reading file. And after that, you want to come here after the comma. So you write the name of its representation, and then you write a comma, open up a single quote or a double quote. It doesn't matter, since Python treats single and double quotes as the same. A single quote writes an R, then come outside of the parentheses and write as. Now I can just give it a name. Now this name is an alias representing the file whose content I am trying to access. So this file is an alias. So an alias is a name used in place of the original name. So I think I talked about this already when I did my tutorial episode on modules. Modules are Python files that have code in them. So just for a refresher, when you say an alias is a name that represents the actual object you are talking about or referring to. So to be able to clarify, when we say object in programming, everything is treated as an object. But for now, since this is an introductory tutorial, I'm not going to bother you with a lot of verbose or programming jargon as of now. But later on, subsequently, we are going to be diving into algorithms, doing projects here and there, blah blah. All right, so this is an alias. It represents the actual file which I'm trying to read from. Then you want to create a variable that will now represent the content of that file. So I will just call it access. Doesn't matter. You can give it any name you want. Now, since file is now the alias representing my contain, which is my reading file, and we were told that when we use the with open command, we are implicitly referring to the file class in Python that allows us to access files. It is only sensible for us to know that since file is acting as an alias of that my file reading, and I'm trying to access the content inside that reading file, we can say that this my file contain and its alias file now represents the class, the class inside Python which we are implicitly referring to. So this file and contain represents that class that we are implicitly referring to. And we have been carrying out this concept for quite a while. So in programming, we basically repeat concepts over and over again. Like in the term of variables and data types are classes. When we create a variable and assign a value to that variable based on that data type, that variable is a representation of that data type. Data types are classes. So that variable is a representation of that class. So we can say that contain is a representation of the implicit file class we are referring to, and the file is an alias of that implicit class file or file class we are referring to. And class, that class in Python that we are implicitly referring to, that allows us to access files, has two functions in it. It has a read and a write function. It also has a close function, which we would be looking at later when we deal with database management. But for now, we are going to be looking at the read and write function in it. So if you can remember, when we created a variable and we assigned it a string value, and then we tried to change the characters within that string value to either uppercase or lowercase. If you can remember, we used some functions called lower, upper, and title. So it's just the same thing. So since that variable represented that string class, we can use that variable to access the functions in that class. I hope that makes a lot of sense. So that's the reason why I'm using file to access the read function. Now this read function allows us to access the content inside that file called contain. Of course, contain is representing my reading file. So if I say contain, I am talking about this reading file that has this text in it. Yeah, I have to do this to explain it very well, like you guys are kindergartens in programming. No offense, but kindergarten in programming, so that you would understand my concept or what I'm trying to explain. So you come here and say print, and then you can write access. So now what will happen is that it's going to print out this text that we wrote. It's going to print it out to the console. So what you have to do is to change it to the current file and click on play, and you will discover that it will print out what we wrote inside that file to the console. As you can see, we have this printed out to the console. All right, so that's how you can read from a file. I hope it was not a bore. All right, so moving on to writing to a file. Now we know that in order for us to read from a file, that file needs to be in existence first before we can carry anything out of a sort. So you want to comment that out. I'm sure we already know what commenting means. You have forgotten what commenting means. It simply means hiding text or hiding code from your Python interpreter. So let's see how we can write to a file. Now we are still going to use the same with open command to write to a file. Now there was something I did not state. Let me uncomment it out so that I can explain. When you are reading from a file, you can either choose to put the letter R here, or you can choose to leave it out and it will still read from that file. We can see the result. The result is still the same nonetheless. So if you take out the R, we are still going to be able to read from a file. All right. Now for the writing to a file, so for writing to a file, it's going to be the same thing. We are going to use the same with open command, but this time around, we are going to use the W letter. So the W letter specifies or signifies that we are trying to write to a file. Now, one thing it does is that when you are trying to write to a file, even though that file is not yet in existence, what happens is that it would create the file and at the same time write to that file. So that's one good thing of writing to a file. You don't necessarily have to create the file before you can write to it. As soon as you execute the command, even though the file was not in existence, what Python will do for you, or Python actually, because the PyCharm is just an IDE that allows us to execute Python code using the Python interpreter. So what Python will do for you is that Python would create the file first for you, and at the same time it will write text and code to that file. So let us see how we can do that. So I want to create another variable again and call it contain2. Now this time around, I would call the file new file. Now you can see that in my folder directory, or in my directory or folder, this file is not in existence. You can see that there is no such file called new file here. So I'm going to run the command, the with open command, of course, using the W letter, and as I execute, you will discover that it would create that file in my directory, in my working directory, and at the same time it would insert some text which I will specify into that file as well. So what I would do, I would just write with open, and at the same time the name of the file which I'm trying to write text to contain to, and W. Now the difference between the W and the R, of course, we know that one allows us to read from a file that is already in existence, and the other one allows us to write to a file whether or not that file is in existence or not. But there is a little more difference other than that. The second difference is that we don't have to write the R when we are trying to read from a file. But when we are trying to write to a file, we must add the W. So that is the difference. So I will come here and create an alias. I will call it file2. And now, since we know that this is an implicit representation of the file class, we know that, and we know that our contain2 now represents that file class. So we know that it can access all the functions in that file class. So we already saw the read function, and we saw that the read function allows us to access contents from a file. Now, the write function would allow us to insert text or characters or contents into a file that was not in existence, but as soon as we execute this command, it would create that file, and at the same time it would write to that file. So now you can come down here and use the alias and say file2 dot write, and then you can specify what you are trying to write into the file. So I will just say this is the second file, first line. Now from the concept we had already learned from white spaces, if you can still remember, just a refresher, white spaces allow us to create, or rather, we have the \n and \t. The \n allows us to go to a new line, and the \t allows us to create tabs or white spaces or some distance from a point in our code to another point. So I will come here, put \n, and I would write another line of text. So write, and I can come here and say this is the second file, second line, second file's second line, so that we would have proper diction as to what we are writing. So this is the second file's first line, and this is the second file's second line. So you want to execute your command, and we can just print out something to the screen so that we can know that our code did execute properly. So I will come here and say print, and print out success. Wow, success, to show that the file really indeed got created. So you come here, click on the play icon, and then we have a success. Voila. Now you can come to your directory and look for that file. Let us scrutinize. Now you can see that it's here. And let us check to see if there's anything inside. Oh my, there's something, there are two lines of text in it. So you can see that we successfully created a file and we inserted two lines of text into that file. All right, so that's how you can read from a file that, of course, needs to be in existence. And this is how you can also write to a file which does not need to be in existence before you do that. But it makes sense too if you create it beforehand before you decide to write to it. So you can comment that out and let's proceed. So this one was writing to a file. You can just give a title there. So writing to a file. So you want to comment it out. Now the next thing we want to look at is appending to a file. So now again, a refresher from the previous topics we did when we talked about a list and how we can append to a list. Of course, appending just means adding extra content to an object in Python or in programming. So we can append to a file. Now you can only append to a file that is already in existence or was already in existence. So what I'm going to do, I can choose either of these files to write an extra line of text to them, either one of them. So I would choose the new file because it doesn't really matter which one you choose, but I'm going to choose the new file. So I will just come here again, write a variable. I would call it append f is equal to my new file. So new file, come here. Now for append, we know that when we are writing to a file, we use R. Sorry, when we are reading from a file, we use R, and when we are writing to a file, we use W. But what of when we are trying to append to a file, that is, add extra content to an already existing file? We use the letter A, that's what we use. It's still the same with open command, and when we are appending to a file, we also use the write function as well. Since we are trying to write content to that file that is already in existence, it only makes perfect sense that we use the write function. So you come here and say with open, of course, and then you specify the name of the file that you are trying to write to, and you say A. I just come here and say as app. Now app represents my file, so I will come here and say app.write. Now because it's text, obviously it's a character, and if you check your new file, you will discover that we already have two lines. Now if I decide to add some text, some new text, it's going to add it after the second line, that is on the same line with this second line of text. So in order for it to go to the next line, we are going to use \n to take it to a new line, and I can come here and write newly added text. Now you want to also write out a message that shows that it was successful. Success. Now you can come here and execute your program and you get a success. Now when we check that file, you will discover that we have a third line of text added to that file. So that is how you can append to a file. And of course, for those of you who are curious, you can create a list and you can pass in multiple file names to that list and you can read from them. You can read all their content one after the other. Of course, using a conditional statement, you can decide to uh, create a condition that tells you which file you are currently at so that you can read its content. Of course, I'm going to talk about that. I won't just leave you hanging. So that's how you can append to a file. Now, the next one we want to look at, we want to talk about exceptions. So we defined both of them in succession. At the same time, we talked about files and we talked about exceptions. But so far, we have talked about reading, writing, and adding to an existing file. But what about exceptions? Now, exceptions simply mean errors. And we have two keywords, that allows us to catch errors and do something else in place of that errors. In place of that error rather. So you want to comment this code out and let us see how we can get started with that. So I will comment this out and I will come here and say exceptions, put a hash since we don't want our interpreter to print it out. So now maybe I have something like this, or I created a variable called name and I said hello there, hello there, and I want to come here and say using an f string, or rather I want to give it a name, Mark, to Mark, and I come here and say hello there, name with a capital letter N. Of course, we know that Python is case sensitive, and then I just disregard the red line and then I proceed to write another sentence or to print out some other command. What will happen? I come here and say continuing what I'm doing. So you will discover that Python would not bother to print out the second line of text you wrote, because why? It's going to flag you and tell you that there was an error in the previous line of code that you tried to execute. So if I run that, you see I get name is not defined. So how do we nip such in the bud? How do we stop such problems? Now, this is where the try and catch comes in. Now, the try attempts to execute some code. Now, if that code had any errors, it's going to direct the execution to the except statement. So I will show you how you can write try and except and repeat this exact same code that we just wrote. So I will come here and say try, and I'm going to try to print this out, create the variable within the try, and just copy it, paste it. So I'm going to try to execute this, and if by any chance I had an error, it will tell me something except. I'll get back to the except in a bit. So you can just write anything you want. So variable spelled wrong. So now what Python will do, and after this I can now come here and proceed to my sentence. So I will just copy it and print it out. And I will comment this one out. So now what's happening here is this. Python did the exact same thing that we did before. But the difference is that instead of this error stopping us right in our track, it's going to do something else and still continue and execute my second line of code. And that is the beauty of try and except. In case you have a very large program that you are trying to execute and you feel like your program might throw up some errors or might hinder its execution, you want to use try and except to be able to catch that error in its track and do something else in place of that error so that you can continue with your code. So that's what's going to happen here. So we attempted to make a sentence with a variable name that is not in existence, and if that variable is not in existence, instead of Python to throw us an error, it's going to direct the command of execution down to the except statement, and it's going to print out this sentence, variable spelt wrong. Then it would proceed and print out continuing what I'm doing. That's what is going to happen. So if you execute your code, you will discover that is exactly what happens. So we get variable spelled wrong and continuing what I'm doing. That's it. That's it. So that's the beauty and power of the try and except. It doesn't allow us to forfeit our large program. It instead allows us to what's the word, do something else in place of that error that we encountered, or we are going to encounter, so to say, and it allows us to continue with our code. So that's it. That's it. So let's look at handling zero division error. Of course, we know that in mathematics we cannot divide a number by zero. So we can also do that with a try. I can attempt to come here and say print 3 divided by 0. We all know that this would not work. You can come here and say except, say print error can't divide by 0. So we get error can't divide by 0. So now another thing I'm going to tell you is that instead of just writing except, if you know the exact type of error that you are going to encounter, you can also write it as well. I can come here and write zero division error because I know the exact type of error I am going to encounter, and this will still print out the same result. You still get the same thing. But to be on the safe side, if you are not too sure of the type of error that you are going to encounter, you just want to just write only the except, only just the except alone. And if you want to know the exact error type or the explanation of the error that you are going to encounter, there is another class called exception. Of course, we know that except is a shorthand for the exception class, which means error. So we can actually write the name in full and give it an alias which will represent that error that you are going to encounter. So you can come here and say except exception as error, and this will print out the sentence explaining the error that we encountered. So I can just come here and say the error message is, and you can come here and say error. Now it will print out an explanation for the error. I'm coming. All right, so it's telling us can't concatenate string, not zero division error, to a string. So we want to convert it to a string. So I will still explain this concept later in the course. So I'll come here, wrap it around the str function, and let us see what we get. So you can see that it tells us the message is division by 0. So it's giving us an explanation of the error that we encountered, or rather the error which was inside the try block before the except statement executed the command. So it tells us that this was an explanation of the error we got, and we know that obviously this is a zero division error. So it's just explaining to us. So what I did here was that I converted the error message that was going to print out. Of course, the error message is not a string value, so it is wrong to concatenate a value that is not of the same data type to a string. So in order for it to be compatible, I decided to convert it to a string. If you can still remember, we did some things like this whereby I came and said int, and you can convert it, you can convert a value like this to an integer, and float can convert a value maybe 34 to a decimal value. So int, float are classes obviously that allow us to convert code to be of that data type, and this one obviously string, it allows us to convert data types from any value into the string data type. So without wasting much time, let's continue. So that's how you can actually um, use your try and except, and it comes in handy when you are trying, specifically for programmers or developers who write large amount of code. So it comes in handy for developers who write large amount of code. Now, another thing I want to talk about is the else block in the try and except. So else in try and except. So I'm sure some of you might be wondering, what is the else doing here? Like, what is it doing here? Well, the else has a part to play, it has a role to play. Its role is such that if the code in the try block is correct or is true, it can then execute a command. So we attach it after the except. So if the code in the try is correct, we can execute what is inside the else. But of course, if the code in the try is not correct, then the except statement would be our guest. So the except statement would instead execute a command for us. So you want to comment this out and let's see how we can test that out. So I would write another program again. I'll come here and say try and create a variable Alex and make a sentence with it. So I would say data is equal to f string hello there name. All right. Now, if there were no errors here, the try block would get executed. So I would come here and say except format. You can decide to write anything you want yourself. But I will now come here and say else print data. So what have I done here? So you will discover that Python would attempt to execute what is inside the try block. Now, if the code in the try block doesn't have any errors, Python would come down here and execute the code in the else, which is of course this variable which I assigned this value to. So it will print out hello there Alex. So just for the record, the else block can see the code in the try block. Now, if for some reason the code in the try block is false, or we get some errors or there are errors there, then the except block will be executed and it will print out wrong format. So we can test that out and you would see hello there Alex. Why? Because the code in the try block is correct. So you can see that we get hello Alex. Now, if for some reason I decided to change the value of name to maybe capital letter E and I try to run this code, you would see that it will tell me wrong format because the value of the variable is not the same. So that's how you can use the else block inside your try and except. So now let's look at handling file not found. So now we want to see how we can merge the concept of try of exceptions and files together. So of course, everything we are learning is to be able to put the piece. They are all just like pieces of a puzzle in which we are trying to put together to actually create something from. So the whole purpose of us learning all these things is so that we can be able to put our ideas together and actually create something that actually works or solves a particular problem in the world. That's just the whole idea to learning programming, nothing else. So handling file not found errors. So handling file not found errors. So you can see that this is also another type of exception, file not found. So let's say I'm trying to read from a file that is not in existence. So I'm going to talk about the problem first, then I'm going to write it down. So you have to conceptualize your problem that you are trying to solve before you get down to actually solving that problem. So I'm trying to read from a file that is not in existence. Now, using the try and except, of course, and then when I find out that that file is not in existence, I want to actually create that file. So I first of all want to read from a file that does not exist, and as soon as I attempt to read from that file, if I discover that that file is not in existence, I want to create that file. So let's get down to it. So I would call the file name file. I'll just call it data value. I would make it um, a text although there's no need to specify for text because it's already a text file already. Then I would come here and say try, and I would say with open. So I'm trying to read from this file. But if you check my directory, the file is not there. It doesn't exist here first. So it's not here, file. I don't see any data value here. Okay, we don't have that. So you come here and you say file, and then you try to read from that file. I would call it as FL. So I'll come here and say result is equal to fl.read. We can see that that file does not exist, and we're trying to print out the result to the screen. So now I will come here and write my except. Now, because we already know the type of error that we are going to encounter, you can choose to write it down by specifying file not found, or you can choose to leave it without writing it. So I already said that if you choose to leave it without writing the actual name of the error that you are going to encounter, the except would allow us to catch every type of error. But you can still decide to write it down if you want. So I will write it down, file not found error, and I will come here and run my with open command again. This time around, I want to create that file. So file, and I will use W2. Then I will come here and say fl2 dot write success in creating and writing. So now, just to let us know that what we did was successful, you can come down here and print success. So what will happen here is that it would attempt to first read from that file to print out the content to the console, but it will discover that that file is not in existence. So then Python would execute the code in the except block, whereby it would create that file and it would write a single line of text to that file, and then our PyCharm would print out, or Python will print out success to the screen. So the first time you run the code, this is what you would get. Now, after you have run this code the first time, if you decide to execute it a second time, you will discover that that file is now in existence and it has this line of text written to it. So the second time you try to execute this code, you will discover that then the code in the try block would now be correct and it would print out this content to the screen. So let's test it out. So you can discover that the file is not here. It was not here initially. Click on play. Now you see we get success. Why? Because it executed the code in the except block. Now, if you check your directory, you will discover that that file has been created now and it wrote a text to it. Now, if you decide to execute your code a second time, the file is now in existence. So Python would execute the code in the try block. You can see we have that. So that's how you can work with files that were not in existence initially, but then you created them and you did all sorts too. So let's see how we can work with multiple files. Working with multiple files. We want to see how we can work with multiple files. So you want to comment out this line of code and what I would do. So I'm going to do a bit of algorithmic, I'm going to try to solve a bit of an algorithmic problem here. So what I'm going to do is that I'm going to write a code that allows me to write to files, first of all. So we're going to write to files, and after we are done writing to this file, we are going to now read from this file. Now, we're not going to write to all the files. I'm going to create 5 files, 5, of which I'm going to create 3. The other 2, I would not. So I will not create the other 2. So after I'm done creating the first 3, I'm going to write different things to them, of course, using conditional statements. And after I'm done, I'm going to now try to loop through that list. Of course, it's going to be a list that would hold these 5 files. So initially, when the list holds these 5 files, these files would not be in existence yet. So I would use a for loop to loop through the list. And as I am looping through the list, I want to be creating the files one after the other. And when I get to the 3rd file, I'm not going to create the 4th and the 5th file. Then a second time, I would loop through this list again. Now, when I'm looping through the list, I'm going to try to print out the content of the files that are in existence. And if I discover, and when I get to the files that I did not create in the first loop, I'm going to print out something else to the screen that tells us that these files are not in existence. So let's get started. So I'll create a list called files. Now the first file will be called file 1, second file, file 2, third file, file 3, fourth file, file 4, and the fifth file, file 5. Now, I'm not going to create the last 2 files, but I will create the first 3 files. So I will create a for loop and I will say for file in files. Now I will come here and create a conditional statement that if file is equivalent to the file at the 0 index. Of course, we know that the file at the 0 index is file 1, obviously. So at that iteration, when the for loop runs the first time, this condition is true. So here I would write my with open command and I would use file there to represent my file, and I'm trying to write something to it as f1. I'll say f1 dot write. I will say first file. So now come here and say elif file equivalent to the files at the one index with open file at that point, trying to write to it as f2, the f2 dot write. All right, come here and say second file. So you can just do that. File is equal to file at the two index. Let me check my battery so that okay, you can still work. So with open file, trying to write as f3 dot write send file. All right, so now I'm not going to create any condition for the last two files like I said. Now I will carry out another for loop again that would allow me to loop through this list, and by the time I run it the first time, we will discover that these files already exist. So what happens, we all know that Python runs line by line. So even though I decide to write the second for loop here, Python would run it accordingly. So it will start this for loop, finish this for loop's iteration, writing first file, second file, and third file to this first file, second file, and third file respectively. And after that, I'm going to create another for loop again. Or let me just finish it before I start talking and yammering. So file in files again. Now I'm going to use my try and except. So with open file read as fx data equal to fx dot read. All right, so what's happening here? I'll do a brief explanation. After that, we are going to stop. Okay, we are going to do one more and then we would stop. So then of course we would continue in our next tutorial. So now what's happening here is this. I looked through this list, and for the first iteration, file represented file 1. So since file represented file 1 for the first iteration, this condition is valid because at that iteration file is file 1 and file 1 is equal to the files at the 0 index. So it's going to write first file into file 1. So I told you that the W, you don't have to create the file, it would automatically create the file for you and write to that file. So it will create that file, and at the same time it would write to the file. Then the for loop would start a second time. For the second iteration, file is file 2. Now for the first condition, it's not true for the second iteration. So Python will check the next conditional statement and see if it is true. So it is true for the second conditional statement because for the second iteration, file 2 is at the 1 index, and I am checking if file 2 is actually at the 1 index, which is true. So it's going to write second file to file 2. And Python, now the reason why Python is starting again, because if you can remember, when we looked at conditional statements using if, elif, and else, we stated that Python looks for the very first condition that is true and executes it and disregards the other conditions. So even though the other conditions after that condition are also true, Python wouldn't bother as long as Python has seen the first condition that was true. It executes the command under that condition and starts and proceeds with its program. It doesn't bother checking any other condition. That is why after Python execute this command after checking that this file is equal to the file at the one index for the second iteration, it creates that file and writes second file to it. It doesn't even bother to check the next conditional statement. Why? Because it has already seen a condition that is true. So whether the next condition is true or not is none of its business. So that's what is happening. So after it creates the second file, it starts the iteration a third time, and for the third iteration, file is equal to file 3, and Python will check if that file is equal to the file at the 2 index. Now don't forget, we start counting from 0. So file 1 is at the 0 index, file 2 1, file 3 3, file 3 2, file 4 3, file 5 4. So Python would carry out the same thing. So for the third iteration, this condition is false, this condition is false. Then for the last condition, it's true. So it will write some text to that file and stop. Of course, the for loop would continue to the end. So it will continue for the next iteration and for the next. But as you can see, there was no condition created for file 4 and file 5. So it fails to do anything for file 4 and file 5. Then this now takes us to the next for loop. So mind you, these 3 files have already been created once this for loop finishes its iteration. Then this takes us back to another for loop, or rather proceeds to another for loop, and then we check. So for the first iteration again, file is file 1. So now don't forget, it has already been created. So Python will now try to read from that file. It is in existence, and Python will print out the result to the screen, which is first file. So you would see first file printed out to the screen. Now because this condition is true in the try, the except doesn't get executed. So like from what we already discussed, the only reason why the except would execute is if the code in the try is false, or if the code has errors, not false, errors, if it has errors. So for the first iteration, file is file 1, it will print out the content and start the iteration a second time. For the second iteration, file is equal to file 2, it is there, we created it in this for loop. It will print out the content, second file, and it will start the iteration a third time. Now for the third iteration, file is file 3, it will print out the content. Now for the fourth iteration, we did not create file 4. So it will come down here and print out file 4 not in existence, and for the last iteration, it will print out file 5 not in existence. So that is what we are going to have. So because we did not print out anything to tell us if it was a success, so we can come here and just add that and say success, and you can also come here and also add that as well. Say success. My battery. Okay. So what you would have is that you are going to have, I'll come here and do that again. So you're going to have success printed out 3 times before you now have the contents of those files printed out as well. And then for the last 2 files that we did not create, it's going to tell us that those files are not in existence. So you can come here and create a new line so that it will not be closely packed together. So you run your code, you have 3 successes for the 3 files created, and then it's going to print out their content, first file, second file, third file, and then for the last 2 elements in the list, which were those 2 files, so you can see that we have the result printed out, success, and it printed out the content inside the first 3 files we created. And then for the last 2 files that we did not create, it printed out the sentence in the except telling us that those files are not in existence. So let's look at, so I hope that was clear and you can confirm that those files are there. If you check your directory, you would see that those files are there. First file, second file, third file. Okay, so that's that. You can comment out your code since if you are done. Now for the next thing, which is the last thing for this series. Sorry, for this episode, not series. Now we want to look at failing silently. Failing silently. So this is when we skip a particular sentence in Python code. That is what we mean. Or rather, sorry, that's not the definition. Failing silently is when we skip the except block in Python using the pass keyword. Now, the pass keyword allows us to skip a statement in Python. Now, this statement can either be a function, a class, a conditional statement, a for loop. As long as it's a statement, it allows us to skip that statement. So it's called pass. So failing silent using pass. So now I can create that list again. File 1, file 1, file 2, file 3, file 4, and then file 5. You can come here and write your for loop for file in files. Then you can come here, try, then you can see which. Oh, so it's still the same command. It's still the same command I wrote here, but when I write the except, it's not going to print out anything. It will just keep that except block. So you are only going to see the sentence printed out or the text printed out in those files that are in existence. So you are going to see first file, second file, and third file, with the exception of file 4 not in existence and file 5 not in existence. So I will come here and say file as f f.read, come down here, print data, then you can just come here and say pass. When you run your code, you are only going to see what we just talked about, the content of file 1, file 2, and file 3 alone. All right, so we get that. All right, so this brings us to the end of this episode. I'm going to continue this episode. We are not done yet, so I will continue it in my next video. So far, if you've enjoyed the video, please like, subscribe, and share. So till our next tutorial video, is goodbye for now.